Alright, thanks for checking out this Six Sigma tool guide. This is Basic Statistics 2. We're going to talk a little bit beyond the mean, mode, and median and delve in a little more to standard deviation, variance, and a little bit into histograms. So if you haven't seen Basic Statistics 1, that's fine. As long as you have a good handle on mean, mode, and median, you should be just fine. Alright, let's get started. So variance, that's one of the subjects we're going to talk about, and what and why. Why is that important? Standard deviation is a measurement, and it helps you understand how much variance exists in your data. And it also speaks to the process that you're analyzing as well. If you saw the video Intro to Histogram, then you saw the example about Bill and Jill, and they had a lemonade stand. They both sold an average of 10 cups per day. It was 300 cups over a span of 30 days. So they both averaged 10 cups. Every day Bill sold either 9, 10, or 11 cups. Most days he sold exactly 10, but always either 9, 10, or 11. And Jill never had a day where she sold 10, even though that was her average. So some days she sold 0, some days she sold 1, some days she sold 2, and then a couple days she sells over 100. So that process, Jill's process, has high variance. When we use that word variance, that's what we're talking about. She jumps back and forth from 0 to 1 to 2 to over 100, back to 1. That's variance. Alright, so standard deviation, what and why? As I said, standard deviation is what measures the variance within your data set. And it gives you a map of your data by using the mean as a reference point and standard deviations as a measurement of distance from the mean. Once you view all this data on a histogram, the shape of that data relative to those landmarks of the mean and how many standard deviations away from the mean you are, those landmarks on the map can give you insight on the process that you're examining. So, standard deviation, here is the big scary math formula. This is the actual calculation. Like most things, it's not as bad as it looks. So standard deviation is a measurement of how spread out the numbers are. That's the most important thing to remember. And the formula is actually pretty easy. It's the square root of the variance. So now you ask, what is the variance? That's a little bit trickier, but it's not bad. Variance is the average of the squared difference from the mean. Seems bad. Alright, so let's calculate variance. As I said, it's the average of the squared differences from the mean. So we figure that out in 4 steps. It's not that bad. Step A is we're going to work out the mean, the average of our data set. Step B is that we then take for each of the numbers in our data set, we subtract the mean. And then in step C, we take those results and we square them. And then in step D, we just work out the average of those squared results. So let's kind of do this one step at a time. Here's our data set. We have a 1, 2, a 3, a 4, and a 5. Let's just say that's processing time to resolve a complaint. So on one instance it took 1 day, one instance it took 2 days, on another instance it took 3 days. Another complaint took 4 days, and the last complaint took 5 days to resolve. So kind of arbitrary, but let's just pick something. So step A, we're going to work out the mean, the average of those numbers. We know how to do that. We're just going to add them all together and get 15. And then we're going to divide it by 5 because there are 5 examples there. So our mean is 3. Step A is already done. Step B, for each of the numbers in our data set, we're going to subtract the mean of 3. So this is our data set. We had a 1, a 2, a 3, a 4, and a 5. For each one of those, we're going to say, hey, 1 minus 3, that equals negative 2. 2 minus 3 equals negative 1, and so on and so on. And then we're going to hold on to these answers that I've bolded here in B, because we're going to use those in step C, where we square those results. So we had the result of negative 2, so we're going to square that. That means taking it, multiplying it by itself, times itself. So negative 2 times negative 2 is 4. Negative 1 times negative 1 is 1, so on and so forth, and that is how we complete step C. Step D is then to take those results, those squared differences, and find the average. So once again, finding an average, not difficult. We're going to add them all up. 4 plus 1 plus 0 plus 1 plus 4, we get 10. Divided by 5, we get 2. Alright, so our variance is 2. We're going to use this number to figure out standard deviation next. Alright, standard deviation. Now, it's pretty easy to calculate. It's a measurement of how spread out the numbers are, and the formula is just the square root of the variance. So the hardest part was figuring out the variance. We just did that, and we know that our variance in that data set is 2. So what is the square root of 2? It is 1.41, and you can get that just on your calculator is the fastest way to do it. But if the square root is the number that if you take it and multiply it times itself, you get 2. So the square root of 2 is 1.41. If you take 1.41 times 1.41, you square it, you will get 2. So the square root of 2 is 1.41, therefore our standard deviation is 1.41. So now what? Why does it even matter? We know what our average is in our data set, and we know what the standard deviation is. What do we do with it now? Alright, so what are we going to use standard deviation for? Well, let's first start out thinking of our data as a city. And if you think of your data set as a city, the mean is at the center of town. And every observation in your data set is an address where someone in the city lives. So an address that's within one standard deviation of the mean is near the center of town. And I kind of said north or south, but if it's either positive or negative, if it's within one standard deviation, then it's kind of close to the center of town. And the addresses that are within 2 standard deviations are a little bit further out, but they're kind of in the center of town still. And addresses that are kind of at that 3rd standard deviation or beyond, that's kind of the outskirts of town. So the more observations that you have at the same quote-unquote address, the taller that building becomes. So if I add a bunch of number 20s, that line's going to go up, that building's going to go up. And suddenly we realize that we're looking at a histogram, and we're using standard deviation to measure how far above or below the mean each of these observations is. So now that we're viewing the data visually like a histogram, we can begin to make observations about the shape of the data. And when you view these results of the process in the form of a histogram, it can give you insight into the process itself. And what do these different shapes tell us about the process? So this is a bell-shaped curve. This is a histogram in what is called normal data. And this is kind of what you're hoping for. You want to have a mean that is right in the middle of your data, and you hope that 68% of your data is within one standard deviation higher or lower than that mean. So most of your data is very similar. So when we think about Bill and his lemonade stand, where just about every day he sold 10 cups, maybe 9 on some days, maybe 11 on some days, but there's very little variation. Most of his days are very tightly clustered together, very close to the average. If 95% of your population should fall within 2 standard deviations in order to have normally distributed data. So that means 95 out of 100 examples are going to be at that mean or within 2 standard deviations, not too far from it. Now 99.7%, so the rest of your population, virtually the rest of it, should fall within 3 standard deviations of your mean. So if you're dealing with a population that is in the thousands, you may have a handful, 1 or 2 or 3 examples that fall greater than 3 standard deviations away from the mean. But they should be few and far between. Virtually all of your examples, 99.7%, are going to be within 3 standard deviations of your mean. If that's the case, you have a normally distributed data, and that's a good thing. It means you have a very consistent process. What's next is understanding where your customer specification limits are compared to this, and if that is hitting the right target or not. Okay, so how do I use this data once you have an understanding of standard deviation? Well, once performance is viewed with an understanding of variance and standard deviation, and you lay that on a histogram with upper and lower specification limits, you begin to understand where you're most commonly performing and where you're not performing relative to your customers' expectations. So differently shaped histograms are going to imply different things about the process being examined. So if you haven't seen Histograms Part 1, definitely check it out. And once you're done with it, check out Histograms Part 2, and we're going to really show you how to interpret the data now that you have an understanding of mean, standard deviation, and variance, and how you fit all of these things together on a histogram. It's going to give you some great pointers on where to start in terms of process improvement. All right, thanks for your time, and like I said, check out the next in the series.